I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about the PACE in artificial intelligence, that is a framework for understanding intelligent agents. Learning about the PACE framework in artificial intelligence is essential because it provides a clear and structured approach to designing and understanding intelligent agents. By breaking down the components of an agent, performance, that is P stands for performance measure, environment, actuators, and sensors. Performance measure, environment, A stands for actuator, and S stands for sensors. It helps us systematically evaluate how an agent interacts with its surroundings and achieves its goal. This framework is fundamental for developing AI systems that are both effective and adoptable across various applications, from robotics to virtual assistants. Understanding peace enhances our ability to design intelligent systems that are well suited to their tasks, improves problem solving skills, and allows for better communication and collaboration in AI development. Ultimately, it equips us with the tools to create more efficient, reliable, and purpose driven AI solutions. We'll see one by one. First, what is PEAS? PEAS. PEAS. P stands for performance measure, E stands for environment, A stands for actuators, and S stands for sensor. So, PEAS is a framework used to define and evaluate the behavior of intelligent agents in artificial intelligence, that is AI. It provides a structured approach to designing and analyzing AI systems by breaking down their components and interactions. The performance measure specifies how the success of agent will be evaluated, helping to set clear goals and determine whether the agent is achieving its objectives. The environment refers to the external context in which the agent operates, including everything the agent interacts with, such as other agents, objects, or conditions. It shapes the agent's decisions and actions. Actuators are the physical or virtual mechanisms through which the agent acts on its environment. This could be motors, screens, or other output devices that allow the agent to influence the world around it. Sensors are the devices that allow the agent to perceive its environment, gathering information needed for decision making. Together, these elements ensure that the agent's goals, context, and interaction mechanisms are clearly defined, making it easier to design, analyze, and understand AI systems. This framework is crucial for developing intelligent agents that can perform tasks autonomously and efficiently. Next, performance measure. We'll see one by one. What is P? What is E? What is A? And performance measure first. That is, evaluating an agent's success involves defining clear, measurable criteria that align with its primary objectives and goals. Say, for example, in the case of self-driving car, success can be measured by factors such as safety, that is, avoid accidents, fuel efficiency, and passenger comfort. Similarly, for a chess AI, it depends on what? Success is often defined by its ability to win games, reflecting its strategic and tactical competence. These criteria ensures that the agent actions are consistently aligned with its intended purpose, whether that is ensuring safe travel, efficient performance, or achieving a high level of expertise in a given task. By establishing these criteria, we can objectively assess the agent's effectiveness in achieving its goals. Next, environment. The environment in which what it refers An agent operates significantly influences its behavior and decision making process. Key factors that define this environment include whether it is fully or partially observable, meaning whether the agent has complete knowledge or only partial visibility of the world around it. The environment can also be a static or dynamic. We'll see the types in later, where a static environment remains unchanged during the agent's deliberation, while a dynamic one evolves over time, requiring the agent to adopt its decisions. Additionally, environments can be discrete or continuous, where discrete environments have countable states and actions, while continuous ones involve infinite possibilities. For example, a vacuum cleaner robot operates in a simple, structured environment that is mostly static and discrete, while a self-driving car operates in a complex dynamic environment that requires real-time adjustment to constantly changing conditions. These factors help define the challenges the agent faces in achieving its goals. Next, actuators. Enabling an agent to take actions in its environment involves equipping it with the necessary tools or mechanisms to interact with and affect that environment. For physical agents, if you are taking physical agent, this might include motors, wheels, or robotic arms, which allow the agent to move or manipulate objects. Virtual agents, if you are taking, on the other hand, interacts through digital means such as generating text responses or executing trades in a financial systems. Task specific actions are tailored to the agent's purpose. For example, if you are taking a drone, the drone uses propellers for flight and camera adjustments for capturing images or videos, while a chatbot uses text or voice output to communicate with users. These actions are crucial for the agent to fulfill its objectives and respond appropriately to changes in its environment. Next, no, the perception, the sensors. Perception allows agent to gather information about their environment, enabling them to make informed decisions and take appropriate actions. For physical devices, say for example, this can involve sensors such as cameras, microphones, or temperature gauges, which help the agent to detect and interpret real world stimuli. Virtual agents rely on data sources like web APIs or user input to perceive and understand the environment. The quality of these sensors is crucial, as high quality sensors enhance the agent's ability to perceive accurately, leading to more effective responses. For example, a self driving car uses the cameras, LIDAR, and GPS to perceive its surroundings and navigate safety, while recommendation systems relies on user interaction data to understand preferences and suggest relevant content. In both cases, perception is essential for the agent to act intelligently and meet its objectives. This is about sensors. Next, why is space important? Performance measure, environment, actuators, and sensors are important. Why peace is important? Systematic design of an agent involves a comprehensive consideration of its various components, ensuring that all aspects such as perception, decision making, and action are well integrated and aligned with the agent's objectives. Customization is key, as well as designed agent should be flexible enough to adapt to diverse applications, whether in physical environment, virtual settings, or specialized tasks. In evaluation is essential to measure the agent's success with clear performance metrics that define how well it achieves its goal. This structured approach not only ensures that the agent functions effectively, but also simplifies communication of its design and purpose, making it easier for stakeholders to understand how the agent works and what it aims to accomplish. So this is what it is necessary. In this way, it is necessary. This piece is important for a agency. Now let us see some examples. So the here, if you are taking the vacuum cleaner, and if you want to measure performance, measure environment, actuators, and sensors, how we are going to define is vacuum cleaner robot operates in an environment consisting of, what is the environment for vacuum cleaner? We are taking the floors, furnitures, and obstacles like walls or pets. It uses sensors. What type of sensors it is using? Pump detectors and cameras to navigate, and dirt sensors to identify areas that need to be cleaning. In actuators, if you are taking, including wheels and vacuum motors, help it move and clean effectively. And if you are coming into the performance measure, its performance is measured by how it has been measured by how clean the floor is, how efficiently it completes the task, and its energy consumption. This is what about the performance measure. Next, self-driving car, if you are taking, self-driving car function in a complex environment of roads, traffic, pedestrians, and varying weather conditions. It uses sensors like, what are all the sensors it is using? LIDAR and a radar to perceive its surroundings, and actuators such as steering, acceleration, and brakes to navigate safety and efficiently. The performance measure of the car is evaluated based on safety, compliance with the traffic laws, fuel efficiency, and passenger comfort. Next, chatbot interacts with the users through what? Text or voice inputs, using natural language processing to understand queries. It operates in a virtual environment and relies on sensors like keyboards or microphones to gather input, and actuators like text displays or voice output to respond. Its important is its performance is determined by accuracy of response, user satisfaction, and the speed of its interactions. Right. Next, the example is the autonomous drone. Autonomous drone navigates through airspace, right? Navigates through airspace, avoiding obstacles like buildings or trees. It uses sensors. What type of sensors it is using? GPS, cameras, and gyroscopes to maintain stability and determine its position. Propellers and camera adjustments serve its actuators, right, enabling movement and functionality. The drone's performance, how it has been measured, is assessed by its navigation accuracy, stability, and ability to complete tasks like deliveries or aerial surveys with a given time frame. So the next example is the recommendation system. It analyzes user preferences and browsing history to suggest products, correct, and content or services. Operating in a digital environment, it gathers data from user interactions and browsing patterns as input through sensors, correct. The system's actuators such as screen displays and notifications present recommendation to users. Its success is measured by the success is measured by relevance of its suggestions, user engagement, and conversion rates. Next example is the medical diagnosis in AI. Medical diagnosis AI processes patient, and the process is the patient data, right? Patient data including medical records and diagnostic images in a clinical environment. It uses sensors like imaging devices to gather input, and actuators like report generation systems to present its findings. Its performance is judged by the, how the performance is measured, this judged by the accuracy of diagnosis, and the speed of analysis and its impact on patient outcomes. So the next example is the stock trading agent. So it agent operates in the dynamic environment of financial markets. All you know that processing real-time data and news. Sensors gather this information while actuators execute trades. The agent's performance is evaluated based on profitability, risk minimization, and execution speed, ensuring optimal trading decisions. Next example is the language translation AI. The language translation AI works in an environment of multiple text or speech input. Sensors like keyboards and microphones capture the input, and actuators like text displays or voice synthesis generate the translation. Its effectiveness is measured by the accuracy of translation and the speed of response, making it useful for breaking language barriers. Next, warehouse robot functions in a logistic environment filled with shelves, bins, and conveyor belts. Using sensors such as cameras and RFID sensors, it identifies and retrieves items. Its actuators, like robotic arms and wheels, enable precise movements. The robot's performance is measured by its speed, accuracy in sorting, and energy efficiency. The next example is the game AI, such as chess playing agent operates on virtual chessboard. It uses sensors to perceive the board state and opponent moves, while actuators what it will do control the movement of game pieces. Its performance is evaluated based on its ability to win games, adopt strategies, and minimize mistakes. Next important application is the weather prediction. Nowadays, we people are using it. What we are doing in this weather prediction? Weather prediction AI processes data from satellites and weather stations to forecast atmospheric conditions. It gathers input through sensors like satellite imaging and weather instruments and uses actuators like a report generation system to decimate predictions. Its performance is assessed by the accuracy and timelines of its forecast. Next, the personal assistant AI, like Sri or Alexa, manages tasks such as scheduling and setting reminders in user-centric environment. It uses microphones to text in and text input as sensors to capture commands and actuators like notifications and calendar update to fulfill tasks. Its success is measured by user satisfaction, task completion, and response time. Next, industrial robot operates in factory environments performing tasks like assembly and welding. It uses sensors such as cameras and pressure detectors to ensure precision and safety, while actuators like robotic arms and grippers execute tasks. Its performance is judged by its speed, accuracy, and efficiency in production processes. Next, fraud detection system monitors financial transactions and user behavior to identify fraudulent activities. It uses transaction logs and activity data as input sensors and actuators to generate alerts when anomalies are detected. Its effectiveness is measured by accuracy and fraud detection and minimize of false positive and negatives. Next example is the search engine AI. It processes the user queries in digital environment, retrieving relevant web pages. It uses sensors to gather input. Sensors. It uses the what is the purpose of using sensor? It uses the sensor to gather the user input and accurate actuators to display search results. Its performance is based on the relevance of results, retrieval speed, and user satisfaction. Finally, the agricultural robot operates in fields monitoring crops and soil conditions. It uses cameras and soil moisture sensors to gather data, and actuators like sprayers and robotics arms to perform tasks like planting or pest control. Its performance is assessed or measured by its ability to optimize yield, remove weeds accurately, and use resources efficiently. Hope all you understood about all the 16 the examples. So coming into the summary, the piece. What do you mean by piece? Performance measure, environment, actuators, and sensors is a foundational framework in AI that helps in systematic design and evaluation of intelligent agents. By focusing on these four key components, piece, performance measure, environment, actuators, and sensors ensures that agents are well equipped to achieve their objectives in various contexts. The performance measure, what it will do, defines how success is measured. The environment describes the context in which the agent operates. The actuators are the mechanism through which the agent interacts with the environment, and the sensors enable the agent to perceive the environment. So this framework is aids in clearly defining an agent's capabilities and purpose, facilitating communication of its design and making it easier to assess its performance and achieving its goals. So, thank you for taking the time to learn about peace framework in artificial intelligence. Understanding peace, that is performance measure, environment, actuators, and sensors, provides a solid foundation for designing and evaluating intelligent agents. By breaking down these key components, you now have a clearer understanding of how agents interact with the environment and achieve their objectives. This knowledge is essential for developing effective AI systems and will empower you to tackle real world challenges with confidence. Keep exploring and applying these concepts to continue advancing your understanding of AI. Thank you once again.